Ladies and gentlemen, welcome to Job Shop USA. My name is Keith and we're in my job shop once again. We're out here in the fabrication or welding bench area. And I've got about 14 or 15 components here that we're painting. And we got other things going on in there, but I wanted to come in here. It's kind of peaceful. This is the day before New Year's Eve, and there ain't too much traffic outside and there ain't too many people knocking on my door. So yesterday I spent the better part of the day just masking and prepping these parts, along with cleaning some other components and taking apart some couple items so that I could get some bearing numbers and a couple other things, because we are progressing with Pearl. Now that we've concluded on the gearbox, I'm waiting on electrical components, a starter for the motor, and I found a nice 2-button push button control that I'll be able to mount in the original position that the 2 mechanical push button switch used to be, before somebody hacked that up and thought they'd put a forward and reverse control. The CK lathe is designed to go in one direction, and it has the features of the lathe with auto return and all kinds of things there. It is nice to have reverse on lathe for a couple things, but it doesn't mean a lathe has to have reverse. You can flip tooling upside down just as easy as you could put it in reverse. Some nice rain hitting the ceiling. I love it out here sometimes when it's like this. Peace of mind and knowing somebody's not going to come knocking on the door. All right. One of the things I really kind of was excited, most of this components here are the taper attachment. And this is the main frame for the taper attachment. And of course you got to paint both sides. And you can see the extent of the masking that I actually worked on to get all of this in. Sometimes I almost swear that the part was painted and then they came in and did the machine work. Some metal surfaces you want to have bare metal, and other areas you want to have the paint coating the product, you know. So I've set this up to where I can finish it up like this, but I can start it out like this. This is just a simple flip over part. And the same here. Now this is the only piece that I actually added some Bondo. I filled in some casting flaws that were in this area right in here. Nothing drastic, but I'm going to start it out this way, and then I'll be able to set it right on the pins and paint that side. This here is the actual guide for the taper, and it's masked off on this side here as well. And of course this is bare. 1/4-inch masking tape is awesome for doing detail curves and things like that, and getting into small areas that you're not necessarily gonna want to have a crinkle in your paper or tape or whatever. Also, I'm able to trim out this ring here, this one here. I just put this over here so I don't accidentally hit that with my brush. This underside here and this underside here are surfaces that don't rub on here. See, this actually sits on top of here. So this is painted, this is painted, this is painted, and just the sides, okay? This is not, and this is not, and these areas here are not. And I think I can paint within the lines. Yeah, today I can. Some of these items we'll paint and then we'll hang them. I usually have a couple areas that I can hang so that I can paint everything that needs to be painted. This is the rods for holding all the rods coming through the apron and controlling. We'll paint this side here and then we'll set it up like this and we'll paint that like that. Some more parts to the taper attachment, and then a couple blank plates for the back of the support on the lathe there, access to the motor area, and this used to go over the switches that are no longer going to be in there. But I figured I'd put some paint on it. It's already cut out. It does look pretty decent on there once it's in place. All right, let's get to it. I'm going to show you actually the paint I use and how I mix it up. Now, normally if I have like some of the bigger stuff, I did a lot of ruddy brown primer prepping and priming on a lot of that surface that I just did needle gun, and then I needed a base on there. And I do that a lot for help smooth out the component, and also if I'm not actually able to blast it 100% clean down to bare metal. Now I'm not going to use primer on these here because I want the color of the paint hard to the metal with as few coats as possible, and it'll have the strength just the same as the primer to stick to these components here, and that's how I'm going to paint these items up here. All right, just to cover, 3M auto tape is what I use. The reason why I picked out the 2-inch and the 1-inch and a 1/4 inch gives me the quick choice for the area you're working on. You see how the detail is done in there. I like using just throwaway cups. The paint I choose on almost all of my machinery is Rust-Oleum, and this is smoke gray. It's a common color I love. About the quantity I think I'm going to use. The one item that I like to add to all my paint, it gives it that hard, crisp, fast drying surface, and it's Japan dryer. They tell you how many drops to add to a gallon and all of that, and I go like this. Real scientific. It does tend to thin the paint just a little bit. We're ready to go. Now, if I'm doing a real large piece and I'm going to be doing a lot, I will use a better quality brush than a throwaway paintbrush. But I just kind of keep an eye out for the hairs that come out of this brush onto the part, and I just try to catch it. All right, I'm not going to make this whole video about painting these parts here, but I am going to start out with my big component here. And I'm just basically showing you that, you know, with the brush, you can really get it into every little nook and cranny. And if you did a good job masking it, you don't have to worry about where you don't want it. And all you got to do is concentrate on the thickness, and then every once in a while you have a hair like that, and with the throwaway brush. But how you paint it and how much you put on there, it'll flatten out and gloss out real nice. Now, if you have texture in your material, you know, because you don't have any of that body filler, especially when you blast it clean again, you actually blast all the fillers that they used. And that's where, like the part I added the Bondo on, you know, if it's important, it's going to be up there on the top, and you want things smooth for one reason, and that's ease of cleaning. Get my block ready for this side here. we go. You want to look nice, because when you pull things apart to adjust them, and or yeah, see, there's a cover that goes on these two screws and these two screws, so it's a flat plate that lays over this whole thing. But when you lift that flat plate to go ahead and adjust for your taper cuts and stuff like that, you're going to be looking at it. You got to do it for yourself, not doing it for anybody else. This being in the morning, this could actually dry up and possibly be able to put the second coat on tonight, but I've got some other things that I got planned already, so as long as it dries for tomorrow, it'll be fine. Now, I'm showing you painting this by brush. I'm not saying this is like any other maneuvers I do in my shop. I'm just giving you options. Not everybody has a paint booth, and not everybody wants overspray hanging out all over the shop. I hate overspray more than anything else. So I'll take the time to do brushing, roller, and come out with satisfactory, to my satisfactory. It's not beating a paint booth and a professional painter, by no means, but it lets you have the option that you can do it yourself. If your accuracy is in the masking, then you can be less accurate with your painting. One of my favorite journeymen when I was a helper at AAA South Shipbuilding, just starting out my career, Joe was a veteran, and he was on an LPH, landing craft helo deck. He was a gunner's mate, and he had a gun turret right by the pilot house. I think the aft side of the pilot house. And he used to tell me, was when it come time and they hit port, they had to needle gun and completely paint the gun turret assembly, the whole bit, and before they could go into port. So he learned real quick, and he would needle gun his gun turret, and then he would put a light coat of oil all over it, mixed it with oil, and then he would paint it. It was complemental in both ways. One, it did protect the areas from getting rusty, but it also let that needle gun fly that paint right off of that thing. And he was done with that gun turret and on his way to shore leave much quicker than the other guys with the other gun turrets and stuff like that. So I had to laugh, because that's ingenious in my book. Well, that was just enough. What I did right there was just finish running the ACME tap down through this piece of material here. Let me move this out of the way before okay. I use this to support this part here. All right, let's take a look, okay? This is the worn out nut for the tailstock. And this is going to be the new lead screw nut for the tailstock. They're both 3 inches long. It was kind of worrisome that I would be able to go through that length of there with the ACME tap, but doing it vertical and then back and forth until we get through with just about that first section of tap, and the second section flows right through. It gets a key. We'll have to put that in on this one, and then this will be ready to install into the bore on the back side of the quill for the tailstock. Also, something I pointed out, whoever made the last one, of course the key went in there like this, okay, and you see that little stain right there on top of that one? See that little oil hole right there? How is oil going to get to those threads if you don't put the oil port down through that hole? I don't know. I know. Now we have a nut to test fit the new ACME threads that we're going to have to turn on the ACME rod that runs the quill in and out. We're going to go set up on the lathe now and do that. On the last page of the Monarch lathe manual here is the tailstock. And there is a few differences on this tailstock in the drawing here and mine. This right here, plate 17, is real skinny on mine, and that's the lifting plate because it's cam actuated. So when the cam cranks, it cranks that plate up against the underside of the center of the bed there, and that's what clamps it down. All right, and I also, right here, part 10, right there, the tang screw, and I actually have the ports for them, both sides, but they're missing, so I guess it's poo on the tang screws, and unless we want to make them up and put them in there. The other thing, this is the lead screw, and you can see the thread visual here, and then like getting wider or flattened out in here. You see how this has actually been trimmed back several times because you keep extending the quill past the point. Oh, I can get another ½ inch out of that hole that I'm drilling, and then you can see, and here you can see that's wiped out. So wipe out and wipe out, that's an inch of travel right there. Then this right here is a screw they put in there, and the drawing is not super clear, but you can see it has a nub on the end there that goes in between the tang screws to knock out the tang on the taper shank if you happen to run a tang. All right, everything else is pretty good, and basically this part right here that we're making is 11. That is your nut. 12 I got over on the bench there. That's the collar that holds this in, and this is keyed in there. So we're going to start roughing this shaft out, and when we get to this point, I kind of like, they made this with a shoulder bolt, which is not a bad idea, and it's threaded in here. Of course, it's not straight in line right here because I can take my new nut here, and with that in place, it wants to screw in there, but you can see that, well, the light's not getting in there, but it's not in line. So it's putting a bind in there, and this edge wants to catch a thread on there and keep it from screwing on there. I'm going to pull this out. I just don't have a wrench on it right now. So I can check that thread. And then this is going to be the no-go gauge, or the proper fit gauge, for our new shaft. Our new shaft is right there inside that solid piece right there. This is 12L14. It's a good leaded stock. Easy turning. This will probably be the first ACME thread that I'm actually going to share. I might have dressed one up along the way, but this will be the first one that I cut from scratch. Alright, I'm just going to get it in the lathe and start on it. I'm heading over in another direction because I just got a few high-tech play toys that just came into the shop. So it's directing my attention right now. Alright, but I'm going to be bringing you in. We'll check it out. I have finished roughing out the shaft, so it's ready to start putting threads on, minus this relief right here. All right, this relief is actually, this one here measures about 593, but it doesn't actually need to be down as far as 593. We can make it a little bit fatter. You gauge that by the threads. All right, now I spent a little while grinding this ACME thread, and the gauge here, we're cutting an 8 thread, or 8 pitch, I should say. All right, so I got it to fit in the gauge, and I have a little bit of play side to side. This is a gauge to make your tip for your ACME that size, and of course this is for angles, and then this is a good setup angle here against your part in the lathe here. We've already done all of that, and I have this ready to go. I will put in my parting tool, and we're going to go ahead and give that relief in there. Now, we took this, and of course, the depth of that is that depth of the thread is half the pitch plus 10 thousandths. So, you know, you can go like this, and actually it's pretty close. I'm reading about 127 on this good area up here, and the pitch of 8 into 1 inch is 125. I mean, it's as simple as pie, but it's just good practice to go ahead and double check and measure in there as well. So 125 plus 10 is 135. 135 from the diameter. This is 745 or so, but 750 is the thread, the nominal thread size there, would make you 615. Now when we did the nut, we went ahead and made the pilot 125. We're reading that pretty close on our pair of calipers here. So we could really make this anywhere between 615, 6.5, somewhere around in there. Like I said, this was 593, and if you actually read like root to root in here, we're getting like 605, 602. Hence, I wanted to make that relief in there pretty close to what the root is without making it too much smaller, because we don't want it to be a weak point. Okay, because this lead screw is only going to be, this is the control of the handle, and this is going to be where the nut's riding, so that's going to be the weak point if there is any. And I notice that this is square right in there. This nut actually may actually come up and come right to that surface right there. So you can't have any interference in here for the root of the thread. You want to, if it's going to back there for the nut stop, then that's what you want it. All right, we're going to go ahead and set up and do our relief right there. And at the same time, we'll be setting up an indicator for in and out. We have our dial. And then we're going to set up an indicator for the cross slide this way. I like setting my cross slide 90 degrees to the depth. That way I can come in, and like I said, I made my ACME narrower than what it needs to be. So once I get it to depth, then I'm going to go forward and aft and kiss off each side of the ACME thread to clean it up and to bring it to size to where this is going to have the best fit. That's how I control my ACME thread, and that's what I'm going to do. Kind of nice having the right tools for the right job, but this is our ACME thread pitch gauge set here, and we've got our leaf out so that we can check it on our first pass. Okay, now we got to set up our thread combination on our closing and get set up here for the right pitch and all of that. So let's see what we got here. Looks like it's all the way down at this end here. Okay. And we'll go with some DA. And we're going to go slower speed. And we're going to go backwards on our feed. All right, this will be actually, I'm going to take 5/1000s. We could go on any number, but I'm going to be cutting this on 1. I'm just going to keep used to cutting it on 1. Okay, now we should be able to get going with no interruptions here. Let's go. So far, we're up to 25 on the depth here per side. $30. $35. 40. I oil it during the start of its cut so that it's all oiled for the start of the next cut. I don't have to worry about getting oil on there before I get started. All I got to do is keep up with my time thread dial. $45. I'm marking it each time, so I got enough time to do that. $50. $55. Okay, this is 60. Okay, 65. Oh, I missed my one. Here we go. After this cut, we're going to do a spring cut. We're just going to let it go by again. We don't know how much pressure we got in the center of this rod here. And then we'll go ahead and kiss our other two in there, and then it's just going to be taken off of each side of our thread until we get the nut to fit. Okay, back to our 65. There's just a friction cut. Kind of like glosses it up. Okay, we're going to go ahead and go 67. Okay, and until we find otherwise, we're going to say that that's our final depth. I'm just taking a couple more passes here just because I know it's just a little bit of pressure on it. All right, that's looking pretty clean. I think it's just picking the chips out of the hole right now. It is taking just a tiny bit right there off the aft side of the thread. All right, I didn't bother checking the nut on here because I jumped right in here and checked the thickness of the tooth. There's about 70, and the inside here is like 60. And then I'm at a good section here. It's like 55 and 70. So we've got about 10 to 12 thousandths that we can thin out the OD of the thread, I should say, and open up the ID or the root. So the valley, we got to open up. The crown, we're going to narrow. All right, we're into depth, and we've got our oil filled up here. We can oil that up. Got the indicator set here. And I'm just going to go ahead and I'm going to take a couple thousandths off of that side of the valley. What we're trying to do is we're trying to bring the root and the crown to match closer to our lead screw. And then we can, as we get real close, we'll go ahead and we'll test the nut and we'll modify it to keep, until we get this nut to fit. But we know we're far enough off right now that we do need to take a couple thousandths off of each side. All right, if we got 5 off of each side there, I'm just going to shoot for a couple here. So we're going to go 2 to the forward side. Or actually, if we were looking at it, it'd be the right-hand side of the thread. All right. Here we go. It was cutting at the beginning and now it's not. I'm just starting to pick up a little bit right now. Okay. Okay, we're going to go ahead, take a couple more. It also could have been because it cooled down some, but she's still cutting all the way here, so it looks like we're going to have a clean cut. That was 5 total. Okay, now we're going to go back the other way. There's 2. She's doing more cutting down this end here, so actually I think it is a temperature thing. Probably did have to normalize there. Okay. And there's a couple more. All right, and she's cutting right off the bat there. I think we're going to be ready for a test bit after this cut. Okay, that is looking good. I mean, we're gonna check the fit, and we're gonna check the measurements at the same time here. And I'm gonna push this away because I don't have 3 inches of travel on that. Okay, I think I'm gonna call it there. It's like 52. That cleans up at like 65, and then this is 71, and this is like 65. So we do have a tighter thread, and I lucked out. I almost munched on the front of the thread there, but I was able to pull out and only just formed about a half a revolution there. The rest of this is good. We have this area here, and then that diameter and that key to put in on that side with the threads for the keeper for the hand wheel. And we just got to decide after we assemble it, we're gonna figure out where this push needs to be to push out a live center without a tang. And then we'll know where that distance is there, and then we're gonna put in something hard here, just in case we put the tang screws in, or make tang screws, and have a tang. I'm glad I got that together, and I'm glad I don't have to put this in. I actually have to get a bigger box of parts that I've thrown out of this thing. Pretty soon it's going to be a whole 55-gallon drum of parts. All right, this is the most important part of this job, and I'm glad I brought you in to see how I actually cut ACME threads, and I'm super happy with this. I got to cut a key in here. I got to turn this key turn this diameter here, and we got to figure out what we're going to do on this end here. But that's after I install it into the tailstock, which is ready on the lathe and just kind of waiting for us to put it together. I have a little bit of work to do on the barrel. We're going to have to pull that key out of there, and this barrel is kind of tapered, and I want to pull that key out of there, and I want to make sure that I have that. I turn the OD to be the right size to make this a better fit. So I want to do that. Everything else on this is in pretty good shape. One note coming up, and this is actually going to be single pointing both parts, the rod and the nut. This is the compound, or the carriage cross slide feed rod, spindly on both sides. I might actually have to set up a steady rest, a follower rest on the lathe to cut that thread. I'm going to have to make a boring bar that will cut that thread. This is not a normal thread. This is 7/8 4. When you say 7/8 4, the other one was 8 threads per inch. Okay, this is 4. So that's really 1/8 of an inch around on the dial. Automatically, you know how far it's going to travel in 1 inch, so you know what the increments are going to be on your dial. This is 4 revolutions per inch, so that's quarter. So 1 revolution on there, and I'm pretty sure I can go pick up the handle for the cross slide, and it'll have 250 degrees on it, marked out for the thousandths of the 1 revolution, you know, per thousandths. I don't know if it was marked in half thousandths or not, but I do know that you're going to be a quarter inch in 1 turn. So there's no tap, and this is going to be a full single point. And I'm probably, without forcing it, just kind of like feeling that free play. I think I'm pretty much in the most worn out area right there. We're moving about 40 thousandths. It's pretty whipped. Going through all of this, I'm not going to put this back in there. So this is going to be another video down the road. All right, thanks for stopping in. Job Shop USA. Till next time, get her done.